Hello friends, in this video I will explain you how you can perform the experiment of SR and D flip-flop. Okay, so first I will explain about SR flip-flop and then after D flip-flop. Okay, so let's start. So for performing this experiment we need 4 NAND gates. Okay, because I'm going to design this SR flip-flop by using NAND gate. We can also use NOR gate, but here I am using NAND gate. Okay, so as already shown in the beginning also, the circuit diagram and the pin diagram of ICs. Okay, so yet I'm going to show you. So this is the circuit diagram which I'm going to use for this. Okay, for this SR flip-flop, this is circuit diagram and this is the truth table for SR flip-flop. Okay, so first I will design this circuit diagram according to this, then after I will verify this truth table, that whether this circuit is working according to this truth table or not. That's I will show you. Okay, so let's start. So 4 AND gates. So for 4 AND gates I'm going to use IC7400. IC7400 contains 4 NAND gates. So here you can see this is IC7400. Okay, so this one I am going to use to perform this experiment. So I'm going to mount this 7400 here. Okay. So this is IC7400 NAND gate IC. I mounted here. Okay, then after here I'm going to make the connection according to the circuit. So you can see as input S is given to pin number 1 of NAND gate. Okay, IC. So here this is as I'm using this gray wire. Okay, here because these all terminals we can use for giving inputs. So I'm connecting to pin number 1. Okay, and okay, before that we have to give plus 5 volt means VCC and ground to this IC. For proper working of this IC, plus 5 volt is required. Okay, so for giving plus 5 volt I'm going to use this here. Now this is plus 5 volt here, so plus 5 volt is connected here, and so that's from here I'm giving to pin number 14. Pin number 14 connected here, or here you can connect, and then ground. For giving ground I'm using here I can connect, and then pin number 7 is the ground. So that's it. Okay, then here is S I already connected in pin number 1 to pin number 1, and R is connected to pin number 5. So I'm connecting, this is the second input R, so that's I'm connecting to pin number 5. So this is pin number 5, so second input connected. Then after you can see pin number 2 and 4 both are connected to clock. Okay, here you can see pin number 2 and 4 both connected to clock. So here, from here I can take clock. For giving clock I'm going to use this wire. Now you can see, so this I'm going to insert here, and then after the other in here this is, so pin number, this is pin number 2, so pin number 2 I'm going to connect. So this is pin number 2 connected. Okay, and pin number 2 and pin number 4 are common, so for that we have to make common. So pin number 2, so this is pin number 2 and pin number 4. So you can see pin number 2, 3, 4. So pin number 2 and 4 I made common. Okay, connected like that. And then after you can see, input part completed. Then after pin number 3. Okay, pin number 3, here you can see Pin numbers I already mentioned. Pin number 3 connected to pin number 9. So according to that, pin number I have already mentioned in this circuit, so that it is easy to connect. Okay, so pin number 3 connected to pin number 9. Pin number 3 connected to pin number 9. Okay, long wire I think I should use. Okay, so pin number 3 connected to pin number 9. So this is pin number 3. Okay, connected to pin number 9. So this is 8 and then this is 9. Okay, pin number 9. 3 connected to pin number 9 and then 6 connected to 13. Pin number 6 connected to 13. So this is pin number 6. So this pin number 6 I am going to connect to pin number 13. So here it is pin number 13 connected. Okay, then 8 is connected to 12. Pin number 8. So pin number 8 connected to 12. This is pin number 8. This is connected to pin number 12. So this is pin number 12 connected. Okay, pin number 8 connected to pin number 12 and pin number 10 connected to 11. Pin number 10 connected to 11. So this is 8. This one is 8, then after 9, then after 10. Pin number 10 is connected to pin number 11. So connected here pin number 11. So 10 and 11 connected like that. Okay. And then you can see Qn, means that is the output. So whatever it is shown in the truth table, so here you can see that here it is Qn, so that is Qt plus 1 here. Okay, so here I can write down Qn also, same thing. Okay, so output we have to take from pin number 8 and pin number Qn we will get from pin number 8 and Qn bar we will get pin number 11. Okay. So you can see pin number 8. So this is pin number 8. So pin number 8. So I'm connecting here. So this is Qn, or you can say Qt plus 1. This is Qt plus 1 or Qn. And the second one, it is Qn bar, pin number 11. So 8, 9, 10, 11. So this is 11. I'm connecting here. So the bottom one, this bottom LED, it is Qt plus 1 bar. So this you will get here just opposite to whatever you will get here. Okay. So Q and bar here it is. So main output here we have, that is Qn. Okay. So main output is this one. So according to table, now you see we have to verify. So when Q0 meaning present state. Now present state, if it is 0, first of all turn on this. If I turn on this trainer kit, okay, so in the beginning, now you see, so in the beginning Q is 0. So how I got, so this one it is 0. Okay, in the beginning it is 0. This is the present state. And when we perform the experiment, then it will be the next stage, that is Qt plus 1. Okay, so present state here it is 0. So in this case, when present state 0, in that case when S are both 0, so output will be 0. So both S and R 0 0, so output here you can see, here you will get 0. So here this one, upper one, you have to see. Okay, this is Qt plus 1. When 0 1, so 0 and 1, so 0 1, and you know this is clocked as our flip-flop. So it means whenever we do whenever we give input, then we have to give clock also. So clock we can give here by pressing this. So when we press, okay, now I will show you. So whether this clock is working or not, I will show you. So you can see I'm connecting this here. this, the second from the bottom. Okay, this one it is the clock. So now you can see if I press, so now clock did not work, so now you see here. Okay, wait a minute, it is not working. Now it will work. Now you can see it means this is clock. So this is clock. Okay, so when I am giving clock, so there it is no change according to the truth table. So when I'm giving clock, then yet output here it is not changing, it will remain as it is. And when S I'm giving 1, so now I'm giving S 1, here S given 1 and R 0. When S 1 and R 0, then in that case next stage it will be 1. So it should come 1 if I press this clock. So if I press clock, so now you can see here it came 1. Okay, if I press clock, so now you can say if I press clock, so then there it is no change, it will remain 1. Okay, so now understood. So then, and when both 1 1, so now if I both 1 1, then in that case in the truth table it is given indeterminate, so it may come anything that is not valid. Okay, so if I press, so that is not valid, so it may come anything. So okay, so that's why. Now next, when now both 0 0 if I do, then you can see when the present state, now you can see here when the present state, we should start from 1. So present state 1 meaning this should, we have to bring 1, so this one we can bring 1 by, now you can see, so now I brought this 1, so present state it is 1. So now from here you have to see that when present state 1, then in that case when 0 0, then output should be remain 1. So when, now you can see here you can see both inputs are 0 0, so both 0 0 means, so there will be no change in the output. So if I press clock, so there is no change in the output. Okay, so if I give 0 1, so 0 and 1, then again out, now 0 1 0 1 meaning S 0 and R 1. So in that case, now you see what will happen if I again press this clock. So now you see output will change if I give clock. Okay, so if I press out this clock, so now you can see here when I gave a clock, then you can say when S0 and R1, then it will become 0. So that's why it became 0. Okay, and then after 1 0, so 1 and then 0, so 1 0 meaning here I have given S1 and R0, then press clock. So now you can see when I gave clock, then it changed here. Okay, and again when both 1 1, so again it is indeterminate. Okay, it is indeterminate, so can come anything. So that's why now you can see this is not valid, because when I am giving clock, then you can see it is changing without any logic. It is working as without any logic. Okay, so in this way we can verify and design the SR clock to SR flip-flop. Now I'm going to explain you about clock D flip-flop. Okay, so D flip-flop is similar to, means only 4 NAND gates we can use and 1 NOT gate. 4 NAND gate and 1 NOT gate we have to use for designing this clock D flip-flop. And the truth table here it is. Okay, I will show you. So this is the circuit diagram. According to this I will make circuit connection, and here this is the truth table. So this is the truth table which we have to see that whether this circuit D flip-flop circuit is working according to this truth table or not. Okay, so for this I'm going to remove this. So first of all turn off this tourniquet, then remove these all wires. Okay, removed. Now removed. Okay, so now in this case, so this one NAND gate IC we need, so that's why I'm leaving this as it is. So one more gate, that is NOT gate we need. So For NOT gate I'm using IC7404. Okay, so this is IC7404. I'm inserting here. Okay, so as you already know that for proper working of this we need plus 5 volt to pin number 14. So I'm connecting this to pin number 14. So connect this to pin number 14. Okay, VCC given. Now one ground we have to give to pin number 7. So for giving ground I'm using this. So connected to pin number 7. So select ground and plus 5 volt given. Now next thing what we have to do, we have to design the circuit according to the circuit diagram. So first only one input. In case of only D flip flop, only one input is, that is D. Okay, so this left gray wire I'm using as input. So this is given to pin number 1. So if I write down the pin numbers, then it will be easier. Okay, so now you can see here I can write down this pin number 1, this is pin number 2, this is 3, this is 4, this is 5, this is 6. Okay, and in the same way now you can see here in case of SR flip flop, in the same way here we can do numbering 9, 10 and 8. So here we can write down 9, 10, 8, and then the bottom one, it is 12, 13, 11. So this is 12, 13, 11. Okay, so you will get this pin description in the pin diagram of IC7400. Okay, so and here I can write down this is pin number 1 of NOT gate IC, this is pin number 2 of NOT gate IC. Okay, according to this I'm going to make the connection. So NOT gate input is given to NOT gate. So now here I'm giving, this is the input of the NOT gate. Then the same D is given to pin number 1 of AND gate. Same D is given to the input of AND gate. So the same input I'm giving to input of AND gate connected here. Okay, then after 2 and 4, pin number 2 and pin number 4 connected to clock. So again pin number 2 and pin number 4 connected to clock. So this is pin number 2 and this is pin number 4. Okay, pin number 2 and pin number 4 connected to, we have to connect to clock. So for giving clock I'm going to use again this one to pin number 2 and 4 here common. So here I connected. Okay, then you can see 2, 4 clock given. Then output of NOT gate is connected to pin number 5 of AND gate. So output of NOT gate. So output of NOT gate means pin number 2 of 7404 is connected to in pin number 5. Pin number 5 of, so this is pin number 5. Okay, pin number 5 of this NAND gate. Okay, so output of these two NAND gates, you can see pin number 3 connected to pin number 9. So pin number 3 connected to pin number 9. So here in this pin number 3, this is connected to pin number 9. So this is pin number 9. Okay, then after pin number 6 connected to pin number 13. Pin number 6, this is pin number 6 is connected to pin number 13. I am going to connect here to pin number 13 connected. Okay, pin number 6 connected to pin number 13, and then after 8 connected to 12 and 10 connected to 11. Okay, so first of all 10 connected to 11, so that's what I'm going to connect. So 8 9 10, 10 connected to 11, so 10 and 11 I'm connecting. Okay, 10 and 11 connected, 10 and 11 connected. Okay, then after 8 and 12 we have to connect. So 8 and 12, for connecting 8 and 12 I'm going to use this 8. So this is 8. Okay, so this is pin number 8 is connected to pin number 12. 8 9 10 11 12, so there we have to connect pin number 12. 8 connected to pin number 12. Okay, connected to 8, connect 12, and then after we have to see output. For seeing output I'm going to use this red wire. So for the first output QT plus 1, it is from a pin number 8. So this is pin number 8, I'm going to connect to the output. So this is QT plus 1 or QN you can say, and the second one it is QT plus 1 bar, so, or QN bar, so that is from pin number 11. So 8 9 10 11, so that is from 8 9 10 and 11. I'm connecting to pin number 11. Okay, and then here, so this is QT, the upper one, this upper LED it is QT plus 1. Okay, now for seeing whether this clock is working properly or not, I'm connecting this to LED. Okay, so sometimes it happens that if clock is not working, then sometimes output it doesn't count. Okay, so that's why for checking that whether the clock is working or not, I connected. Now then after turn on this trainer kit, when we turn on, so in the, now we have to verify. So when present state is 0 0, so when present state is 0, so now you can see present state here it is 0, the upper LED here it is 0. Okay, this one. So in this case when data is 0, so when data is 0, then output it should be 0. Okay, so output is 0. So how? So when we press this clock, then we have to see now clock here it is working, clock is working, but here output is 0 when data is 1. Okay, so when data we give 1, so now you can see here I gave 1 data. So if I press, so now you can see when I pressed, then clock worked, and that's why the output it became 1. Okay, and then after when present state is 1, so now you can see present state is 1. Okay, present state here it is 1. So when we give data 0, so when we give data 0, so output it should be 0, means whatever we give input, the same thing it should come in the output. So we gave input 0, so that's why output it should come 0, the upper one. Now you can see here it became 0. Okay, so it is working now. Both means data present state 1 also, and data input also 1. So present state, first of all we have to bring 1. So this is present state 1. Okay, and present state according to table 1, and when present state 1, then when input we give 1, then we have to see that the output it should be 1. So now you can see clock worked, here it is clock working, but yet it is remaining 1. It means two table of D flip-flop, clock D flip-flop verified. And this way we can perform the experiment of SR flip-flop and D flip-flop. Okay, so thank you all.